I got a new project that I'm about to start on, and this is one that I wanted to go ahead and try to get a little video of and share with you. These are going to be some ends for a cylinder, hydraulic cylinder, a tie rod cylinder. So this would be the, like, you know, the head and then the butt end of the cylinder. And so what we got is some 3-inch thick A36 plate that's been flame cut. And what are they? So about 7 3/4 square is what they are. We got 2 of them, and I got a couple little pictures here that I can show you. Now this is one that there's an existing cylinder that we've serviced several times, you know, rebuilt it, reseal it. Sometimes we have to make a new rod for it, a new gland, and it's not one that the customer can buy. It's not made anymore. So what they want is us to build one so that they'll have a spare on their shelf, so that whenever this thing, if it starts leaking and they need to pull it out, it's not such a rush to try to get this done and then be down, which is really important in this business. Something that we want to talk about later is asset strategies. But anyway, what we're going to do is focus on building these parts right here. And I actually had to build the entire cylinder, the rod, the barrel, the tie rods, these heads, and the gland. But we're gonna show these right here. So this is one of it right here. That's one end. And we got to bore a hole in it. We got to drill some holes. I'm not going to worry about the outside. That's not critical. I'm going to locate the center of it and just work off the center of the plate. And then there's another one. There's going to be the butt end right there. We're going to make a couple modifications to that. It's not going to look exactly like that. So we've got some face grooving to do right here. This is where the tube will actually fit in there, and on this inner lip right there is going to be an O-ring groove cut in there too. All right, so not a whole lot, but still quite a bit of work to do. So I'm going to show you some of this work as we move along with it. We're just doing a center. All right. That'll allow us to locate the center when we go to indicate it. I like to take the cutters out whenever I take stuff in and out. I made a mistake one time and picked the vise up off the do-all mill, and there was a center drill in here, and it jammed straight in the middle of my thumb down to the meat. And let me tell you, that didn't feel good. Get the jaws preset, and then just open up 2 of them so that you got a little clearance to get the part in there. Alright, we're within a 1/4 mile. We'll get her indicated in. First thing I'll do is make sure it's seated against the forejaw. We'll use that back face as a reference. Wherever that's sitting at, we're going to go ahead and face this side, and we'll have to flip it around and do a counterbore on the other side, and then this flat face after it's machined will be our reference for the other side there. So here's my trick that I'm going to use to find the center. This is a good use for a dead center. This is a number 5 Morse dead center. And don't put it in there really tight. Just barely put it in there. For that end to be true, you can indicate this in here. leave the tailstock locked just barely snug. And what you're doing there is this thing finds the center. It gives it enough movement that it can actually push it back so it doesn't bind up on you. The half a thou. We're gonna go ahead and start drilling our hole. I'll just start with like I think that's a 7/16 drill, and I'll just move up to probably a total 2.5, and then bore it from there. And it's gonna have an initial bore of 4.5 inches. And then on the outer side, which is going to end up being on the back side there, it's going to have a 5-inch diameter counter bore in there. That's part of where the gland actually seals inside there. So we'll get started making a hole. This is a 1 3/4 drill bit, and after I drill it with this, I'll go in there with the 2.5-inch drill. Now, that's just my personal preference to step drill like this, because I don't like taking a big drill and center drilling with it. It's just too much pressure to try to crank it. I use a small drill just to make a pilot hole. That way the web in the center of these bigger drills ain't trying to pilot itself. And once you get it started, man, you can just really push it in there. Just back off every half or quarter turn just to break a chip. That grind is off a little bit because you can notice the chip on the bottom is a little wider than the chip that's coming out of the top. No really big deal, because most of the time when we're using these drills like this, it's just to make a hole. We're not using it to drill any kind of precision diameter. All right, here's our 2.5-inch drill. Let off the hand wheel, like I was saying, and break the chips so that it's easier to manage them. So here's another fun way to make use of the Noga mini coil right here. Just got it sitting, it's got the mag base, and you can adjust air pressure here, adjust nozzle, you know, the amount of water coolant that you want out of the end right there. I've got her kind of adjusted where it's blowing up inside there. Alright, so that's helping to keep the chip blowed out away from the tool as it's cutting, and it's helping to cool the parts. Just mix a little bit of that with some water, and good way to have some coolant without the big mess of actual flood coolant. Alright, so I'm down to just a kind of like a cleanup cut right here. Just taking about 25 thousandths out of it and gonna get a smoother finish, and then I'll mic it, see what we got. It should give us about 50 thousandths to bring it to size. Alright, I'm gonna use the telescope gauges to see where I'm at here. .451. I'll double check it. So what I'll do is since this was already a light cut and it's cleaning up, I'm going to split it, take it in 2 cuts. Well, you had virtually the same tool pressure for each cut. So we need 49 thousandths to come out of there. So I'll take 25 thousandths for this cut, mic it, and then take whatever we need for the last cut. In fact, I'm going to go ahead and speed it up. We'll go up to 420. Yeah, this is going to be 420. Part's nice and cool. Barely any warmth to that at all. This bore isn't a critical bore. The one that we're going to do on the other side, the counter bore, needs to be on size because it fits a gland. Let me see if we hit it around 75, 76. Yep, 76. So we got 24 thousandths. I'm going to go ahead and double check. I'd say that's right at 76, maybe 1 or 2 tenths under. I'm going to dial in 24 thousandths and make a cut. 10, 24, and I'll bring it back and we'll measure it, see where I hit my size. And then when I retract, I'll move the bar out of the way so it doesn't drag. Look at that finish, pretty nice. Let's see what we hit on our diameter. That's just touching right there. If you want to get technical with it, I would call that. So 499 and 9 tenths. Not bad. Okay, let's move on. So our drawing says that our part is going to finish at 2-inch 960. Alright, this is 3-inch nominal material, but this plate stock like this, hot rolled anyway, always comes a little bit oversized. So if I use a mic just in one random spot, we're getting basically like 30 thousandths over. Okay, so that's 40, 50, 60, 70. So we got about 70 thousandths to face off. So I'll just make one cleanup pass across this side right here, get it nice and true. We'll have to chamfer the inside, and I'll leave the rest of the facing for the other side. Get everything set here the way I want. I had to move the compound back a little bit. And I think that's going to be pretty good right there. So I'm just going to touch it. I'm all the way back. All right, good. Looks like we're hitting just hitting that side. So we got 3 corners that we're touching. It is touching all 4, okay. So I'm gonna go in, I'm gonna dial it in 30 thou. Angle of the tool and the feed rate ain't liking each other. That's why we're getting the stringy chips there. I'm just gonna let it roll though and try to make that cut. When it finishes right here, what I'm gonna do is I'm gonna stop the feed, stop the machine. The least amount of chance I have for getting over here and getting caught up in chips if they get caught in there and fling around. This is going to be our face grooving op. I've already got the tool set where it needs to be. So the tube is going to fit in there, and the idea of the tube is 6 inches. So the diameter of the groove there will be 6 inches there, minus a few thousandths for clearance for it to fit in there. And the groove width is going to be just over 1/2 inch, and we're going to go 1/4 inch deep. So this is my face grooving tool. This is my ISCAR face grooving tool. It's made for plunging into a face there. I had got this back when I made the rotary welding table and used on that shaft. Works really good. I'm going to use my mister over here to help us out while we're cutting it. I'm going to touch it. I'm going to go ahead and touch off here and zero everything. Alright. Zero the X. I just want to verify it again. We should be about 6 inches right there. Yep. So touch the ID, offset it the width of the tool, and then moved over 3/4 of an inch. Alright, let's try our coolant. I'm not going to flood it as much. Let's see. Got to get the little plunger set in there right. And we'll try that right there. See how that does. Now just hand feed. I don't power feed this thing in there because I like to feel it. That's 100 thousandths deep. Just is clearing that bottom, that radius. We're halfway there. I got to get some more coolant. The bucket's about empty, so it's not siphoning it up, what it's doing. Let me go ahead and do that. All right, let's get back in there. We got fresh coolant. Here we go. Guess I need to check that lens. Yeah, we're clear. All right, we're gonna go back in. We're right at 200 deep. $235. All right, that's $250. Now, think I got any on the lens there. That's keeping everything lubricated and cool and that kind of stuff, keeping the insert nice. Let's go ahead and offset it and make another cut. So it should be about 312. All right. See if I can clear those chips a little bit better by pecking it, just to break them and get them to fall out of the way instead of wrapping up. About 50 thousandths to go. Now we're close. 312. Okay. That's right, I didn't offset it the full width of the tool. Alright, so you kind of see what we're doing right there. I'm going to go ahead and offset it. I'm going to get it cut to the proper width and clean that up. You see that little razor edge up in there? That's from just pushing off because it was right on the edge of the tool bit. So clean all that up and get it cut to the width. I'll bring you back. So I've got it cut to width. So what I'm going to do is trim it. I'm going to take 4 thousandths off that ID right there, and then we're going to trim the back face of it out. Just kind of clean it up. Went in about an extra 2 thou right there. Oh, one more revolution. I thought I was at the end right there. Gotta come around again. Okay. I think we're there. I think that's where we're going to need to be. Just going to use these and see about where that's at. Yeah. I'm wanting about 4 thousandths under right there. So I think that's got us where we want to be right there. And as far as this diameter, our tube is 7 inches. It's actually, I think it was like 5 thousandths over, and I wanted to give it a little bit of clearance. So 7 inches 20 thousandths is what I cut this right here, just so to have a little bit of clearance. So I give it about 15 thou clearance or so.